Everyone, I'm Dexter. Today in this video I would like to demonstrate for our embedded microcontrollers lab 4. It's about assembly language. So basically this is our circuit. As you can see, we are using the MCU to run the 7 segment. So basically for this assembly language, we are using for this lab, we are using assembly language to run the 7 segment display. So here's the code. Here is the where we assign the GPIO, C and D, where we using because we are using port C and D. Here's the main routine of our assembly code. We just basically push the link register into stack, then we compare the R0, as we know that the R0 is connected to the output of the C program. So we just basically compare, and then we branch equal to the each of the subroutine, from 0 to 9. So here's the subroutine for each of the output display. So let's run this program. Here, as you can see, the value is running from 0 to 9 because in fact, actually, when we are writing in the assembly in this way, the circuit won't be running like this, but then I include a for loop inside the C program. That's why we can see with delay, and then so that's why we can see that it is running. So move on to part B. So part B basically is the same thing, but then we are just including the delay module. So basically we are using assembly language to run the delay function instead of using C programming. So here's how I did for my assembly language for the delay. So basically the main function is the main routine of the assembly is about calling the subroutine of by sequence from 1, and then we will be delay. This one can be further clearly seen. So I will be showing you the flow chart of the process. So basically the delay module will be start off by loading the R4 with a value of this, and then subtracted by 1, and then to check whether the R4 is 0, it will be a loop until it reaches to 0, then it will finish. So this is about the delay module. So let's run this program. Okay, so in order to show that the 1 second delay, so we'll start off by using the stopwatch. So let's start. Wait, hold on. So when it's reaches 0, we'll start. Okay, let's start. As you can see, it's actually moving in 1 second delay interval. So that's all for part 2. Thank you.
this is our code. So in lab 4 part 3, we are adding a switch to our 7 segment display with assembly language. So first of all, define as usual as a part 2, and then input mask. So in this part we have input for switch. We're using okay, so we define the input mask as 3. There's no shift, and then for another port is it's also 3. It's equal to binary 11 binary number. So this is our delay function initialize. The difference between this section and section 2 is that we have the input, so we need to initialize the input port as active flow, so we don't need the drive string, and then PDDR and with our input. So here's come the main function. We're using 2 different ports. So the first port, port D, we shifted 0, and then the port N will be shifted by 2, because if there is no shifted here, the number with the bit cannot be added, cannot be n, because there's 211 here, so becomes the same answer lah. Then after shifted, so the answer will be this 4.1 here. As our assembly language is about similar with part 2 to light up the 7 segment. So we debug. Okay, play. So it's on 0. This is active flow, so we connected to ground is in the logic 1, then we put ground is in logic 0. So this is 1, and then 2, and then 3, and then 4, 5. So we have 6 over here. Oops. 6, we have 7, and then now it goes to 8, 9, and then if every pin is unplugged, is equal to 0 as well. Okay, thank you. That's all from me.